Why not?
Where do you work? Yeah. You actually? Really? Really? You work with 9/11? Yeah. Wow. That's cool.
Okay, so today we want to do a few problems in your homework together, and it's the same concept. We are going to graph parent functions and look at the transformations. The difference here is that we are going to look at functions that you're maybe not quite as familiar with. So these shapes you need to commit to memory. We already took notes on them. They're in your library of parent functions. And this parent function is y is equal to 1 over x. Who remembers what 1 over x looks like? It's the reciprocal function. Very good. It doesn't touch the axes. So it has this vertical asymptote and the horizontal asymptote. And it has location here, and it has location here. And that's the reciprocal function. So the question is, can you identify then the transformation that's happening? You see the plus 2, so what's that? What do you think that's telling us? Do you think it's left 2 or up 2? Let's look at the difference here. Notice in this situation it's 1 over x plus 3, whereas here it's 1 over the quantity x plus 2. So it's left 2. This would be a vertical shift. This is a horizontal shift. So if I move it left 2, is that going to change the location of the vertical asymptote? Yep, so your vertical asymptote changes location. How about the horizontal asymptote?
No.
Nope, that does not change location. So that sits right where it is. So notice here that you have your first one there and your second one here.
Does that happen to get the line to it?
No. I don't like it when you draw these if you draw it like that. You know, it doesn't, I mean, first of all, this is not a function. It doesn't pass a vertical line test, you know what I'm saying? I don't like if you draw it all the way past there. You know, just try to approach the line as best you can. The next one, you may say, well, Mr. Gantz, we didn't talk about that. Well, we did. This is the cubed root of x minus 3. So do you remember what a cubed root function looked like? Looked like that, didn't it? Because the domain of a cubed root is all real numbers. You can take the positives and the negatives. So that's our cubed root function. What's the transformation here? Right 3. Yep, very good. So I'm going to move it right 3, and then this is my transformation. So the square root function, just to be clear, it looks like the green if I just cut off that end, right? So the cube root just has the other side to it. So they're very closely related. The next one, never mind the 2 on top. The 2 doesn't make any transformation, but the negative does matter. So what's the negative on the outside going to do? Flips it vertically. Very good. So it's going to be... So the 2 actually creates a stretch, and we haven't talked about a stretch or compression, but in terms of its location, moving it right or left, it doesn't do anything. It doesn't, okay? So we're teaching you to ignore that constant, and we'll have another example where that happens as well. So notice also it's being squared. This 2 does matter. Do you remember what happens if they're squared? Do you remember what happens to their locations? If you square something, it's going to be positive, so they'll both be above the x-axis. Okay, so the parent function looks like this. That's the parent function. When you square it, they both become positive. We have a different situation here. What's the minus 3 going to do? Right 3, and then the negative, what does that do? Flips it vertically. So in blue, I will draw the transformation. That's the transformation. Question? Okay, this one right here looks very similar to what we did in our checkpoint, doesn't it? Okay, so I'm going to go ahead and factor out a negative. Y is equal to the square root of a negative quantity, and the 4 minus x is going to change to what? X minus 4, good, and then plus 1 on the outside. So the minus 4 is going to move it to the right 4. The negative on the inside is going to create a horizontal flip. Okay, yep, so instead of heading off to the right, it's going to go off to the left, and then the plus 1 moves it up 1. So right 4, up 1, headed off to the left. Okay, the next one. Doesn't it look weird with that 4 in front? So what if we just rewrite it to be y is equal to negative quantity x minus 2 to the 5th, and then we do plus 4 on the end. Can you convince yourself that those expressions are in fact the same?
Yeah.
Good. So what do you think a 5th degree polynomial will look like? Yeah, it's going to look like the cubic, right? So it's going to look like this. Okay. I don't have to like notice the difference between the cubic and the 5th degree one. You know, just draw something relatively similar to that, and that's going to be fine. So the minus 2 will move it right 2, up 4, and the negative does a vertical flip. Very good. So I'm going right 2, up 4, vertical flip. One over x plus 3. We already talked about this one. It's going to look very similar to the first. We know that the parent function looks like this. What's the transformation going to be? Up 3. Does that change the vertical asymptote?
No.
Nope. How about the horizontal asymptote?
Yeah.
Yep, the horizontal asymptote is shifted up 3 units. And the vertical asymptote sits right there. Are these going to sit right next to each other or opposite quadrants? Opposite. What's different about this next one? Yeah, you see the 5th degree. See the 5th degree. Do you think that's going to look more like the 1st degree one, or do you think it's going to look more like the 2nd degree one? It's going to look more like the 1st degree because it's odd. Okay, the odd is what makes it in opposite quadrants. The even is what makes it in the same quadrants. See that? So if you see an odd power in the denominator, then it's going to be an opposite. If it's even power, it's going to be in the same. So the parent function looks like this. So what are the two transformations that take place? Right, 3 and the negatives on the outside, we'll call that a vertical flip. So I moved it to the right 3. If I make a vertical flip, it's going to be here. It's going to be here. Four more left. I'm going to give you time to work. What's that? Look at this guy right here. What's different about that from what we've seen so far?
We have a 2 in the...
Yeah. Yep. The 2 is causing an issue for us, and this 4th root. Do you remember what a 4th root will look like? It's going to look just like a square root. So what I'm going to do is try to get a better feel of what's going on here. I'm going to factor out the 2. So I have the 4th root of 2 times x plus 3. So anybody want to guess what that's going to do to it? Shift it to the left 3 units. The 2 actually creates like a horizontal compression or a horizontal stretch. You don't have to show that. We just want to see the whole thing move 3 units to the left. We're going to talk about horizontal compressions and stretches tomorrow. Which one is this like on the board that we've already done? Yeah, the second one. So this is going to have the shape of the cube root function, which is like that. What are the two transformations here? Left 2 and a vertical flip. Yeah, that wasn't very good, was it? I started to trail off in the opposite directions. Okay, 2 more. I'd like to look at this one. Negative cube root of x squared plus 4. So if we try to remember what this looks like, it's a negative x to the 2/3, and then it's plus 4. So let's try to remember the parent function, x to the 2/3. If you square something, it's going to be positive, right? And if you cube root a positive, it's going to be positive. So it turns out that whether you plug in a positive or a negative, the output is going to be positive. So this is what the parent function looks like. It's the bird function. And what are the two transformations? Yep, up 4 and upside down. That wasn't bad, was it? Okay, and then flip it over. We'll do one more. Sir. So in this situation, this one right here, notice it's a 3 minus x in the denominator. So, if you factor that to be a 3 over and then a negative, and it would be the quantity x plus 3. I'm sorry, x minus 3. Sorry about that. I just want you to understand, like, every polynomial is a little bit, or every function is a little bit different. But when you factor the negative out, whether the negative is on the bottom or the top or out front, the point is there's just one negative. It could be located at the top, the bottom, or out front. It has the same impact. So in this situation, our parent function looks like this. Does the 3 in the top do anything? No. What does this minus 3 do? Right? 3, the plus 2 will move it up 2. Then what does the negative do? Yep, vertical flip. So I'll go right 3, I go up 2. So that's where my new set of asymptotes are going to be. And if I vertical flip that guy, I'm going to have this part, and I'm going to have this part. And that's what I have. So that's going to give you about 12 minutes. My guess is in 12 minutes you could probably get done with a page. We already did one page together in class, didn't we? So that'll cut down a little bit of work for you. Be ready to go tomorrow. We are going to miss Friday due to the college fair, so we need to make sure that we get our proper lesson in. Okay. So you're going to do all these graphs of the parent functions, transformations, the harder ones. Yes.